In Lesson 4.5, we are entering the exciting world of graphing linear equations. You'll get to determine whether an equation is linear and graph linear equations. How can linear equations be used in nutrition? Well, you see, nutritionists recommend that no more than 30% of a person's daily caloric intake come from fat. Each gram of fat contains 9 calories. To determine the most grams of fat, F, you should find the total number of calories, C, you consume each day, and use the equation. F equals 0.3 times C divided by 9, or F equals C divided by 30. The graph of this equation shows the maximum number of grams of fat you can consume based on the total number of calories consumed. The standard form of a linear equation is ax plus by equals c. You need that in your notes for sure. Where, and then they give us all these rules, a has to be greater than or equal to 0. So they want the coefficient of x to be positive. A and b are both not 0 because then you wouldn't have much of an equation. A, b, and c are integers, so no fractions or decimals, whose greatest common factor is 1. So if we can divide something out, we should. For example, 1a, they ask us to determine whether 5x plus 3y equals z plus 2 is a linear equation. If so, write the equation in standard form. Well, we just said a linear equation is in the form ax plus by equals c. That is not a constant. There is an extra variable. So that is no. Okay, B looks more promising because at least I only have x and y. I am not supposed to have any fractions though, so I need to multiply both sides by 4 to get the fractions to go away. So we'd have just 3x equals 4y plus 32, and then we would need to move the y to the other side with subtraction. Give myself more room. So it would be 3x, subtract 4y from both sides, so minus 4y equals 32, and so that would be a yes, and that's the standard form. This one looks pretty good. I've got a 3x minus 6y equals 27. The only thing that I'm not supposed to have is they all have a common factor of 3 that I can divide out. So then I'd have x minus 2y equals 9. So that one was a yes. A is 1, B is negative 2, and C would be 9. This one looks interesting. I don't have a y. I have 1/4 x equals negative 7. It didn't say I had to have a y, it just said a and b could not both be 0. But I can't have a fraction, so I need to multiply both sides by 4. So I'd have x equals negative 28. And so that one would be a yes. And if we graph that just for fun, negative 28 would be 28 places to the left. That'd be a vertical line. So yes, it is a linear equation because the graph makes a line. Here we go to meat and potatoes. Graph the equation. We can graph any equation we want if we just solve for y and put in enough values for x to give us values for our dependent value y. I want to get y on one side by itself, so I'm going to add x to both sides of the equation. So I have 1/2 y equals 1 plus x. Then to get rid of the 1/2, I'm going to multiply both sides by 2. So 1/2 times 2 is 1. And then I have 2 plus 2x. Now the fun begins. I can make a table of values. I can put any numbers into that table of values that I would like. I think I would like negative 3, that's an ugly 3, negative 1, 0, 2, and 4. For my x is my independent variable. And then I can find the values for my dependent variable using that equation. So 2 plus 2 times negative 3 would be negative 6 would equal negative 4. 2 plus negative 2 is 0. 2 plus 0 is 2. 2 plus 4 is 6. And 2 plus 8 is 10. So now from my table, I've got 5 ordered pairs. We can graph them. So we're going to plot the points. I've got negative 1, 2, 3, negative 4, negative 1, 0, 0, 2, 2, 6, and 4, 10. Shayangatai walks his dog 2.5 miles around the lake every day. Graph m equals 2.5d, where m represents the number of miles walked and d represents the number of days walking. They picked the numbers 0, 4, 8, 12, and 16 for the number of days. So those would be our independent variables. So the dependent variable time, 0 times 2.5 is 0, 2.5 times 4 is 10, 2.5 times 8 is 20, and 2.5 times 12 is 30, 2.5 times 16 is 40. And those gives us our nice little ordered pairs that we can now graph. And I like using the worksheets on these lessons because they would give us a graph that's already labeled. They went by 4s on the independent variable, the days, and they went by 10s, the dependent variable, on the miles. I wonder how they picked those numbers. Suppose Shanghai wanted to walk 50 miles. How many days would it take him? So now we know how far he wants to go. And we've already made this lovely graph. We could solve it algebraically too, but here's the graph. He wants to walk 50 miles. So 50 miles happens to be right on the edge of their graph there. So if we just go down, we find that it would take him 20 days. We could also do it numerically. If we added 4 more to our days column and took 2.5 times 20, we would get the 50 miles that he wanted to walk. You can see that pattern's going up by 10, so you could have seen it right there as well. Since 2 points determine a line, a simple method of graphing a linear equation is to find the points where the graph crosses the x-axis and the y-axis. The x-coordinate of the point at which it crosses the x-axis is called the x-intercept, and the y-coordinate of the point where the graph crosses the y-axis is called the y-intercept. To find the x-intercept, I want to take my equation and substitute 0 in for the y value. So divide both sides by 4 because minus 0 doesn't do anything. So x equals 1. So I have the ordered pair 1, 0. And then I'm going to do the same thing, only I'm going to substitute 0 in for x. So I have 4 times 0 minus y equals 4. So 4 times 0 is 0. Negative y equals 4. Divide both sides by negative 1. So y equals negative 4. So that's the ordered pair 0, negative 4. So first we need to plot our 2 points. We're going to plot 1, 0, and 0, negative 4. And then we can take a straight edge and draw a nice line that connects them. They did a great job in their graphic because they have labeled the line and they have labeled arrows on both ends of our line because a lot of people want to just draw a line that connects the 2 points. That would be a line segment. A line, you'll learn in geometry, continues forever in both directions. In standard form for a linear equation is ax plus by equals c, where a is greater than or equal to 0, aka positive, and a and b are not both 0. To find the x-intercept, let y equal 0. Solve for x. To find the y-intercept, let x equal 0. Solve for y.